Integrated Math 1. Welcome to lesson 2.1.5a, where we are doing day one of comparing linear functions in different forms. So we already know linear functions can be written all kinds of ways, right? Tables, graphs, equations, scenarios, right? I mean, we've seen so many different ways to write our linear functions now. We're going to just kind of compare things. But before we do, can you just take a moment to determine whether each set of ordered pairs represents a function? Remember, to be a function, every input gets one output. That's the deal. Every input gets only one output. X is the input, Y is the output. So go ahead, hit pause, tell me if it's a function or not and why, and hit play to check your work. So let's see, -1 only has one output, 0 only has one output, 1 has one output, 2 has one output. I'm going to say that's a function. -1 has one output, 0 is one output, 1 has one output, 2 is one output. Awesome. You're also a function. -1 has one output, 0 has one output, 1 has one output, 2 is one output. Good job. You're also a function. And it's okay if they share outputs. We're cool if they share outputs. That's okay. Uh-oh. -1 has a whole bunch of outputs. Shame on you, -1, getting greedy, stealing all the outputs. And for that, you're not a function. That's not cool. So let's compare our linear functions in different forms. So we're going to compare linear functions because we know they can be represented algebraically, graphically, tables, verbal descriptions, right? We write equations. We could do all kinds of things because that's just how it goes. We're going to choose and interpret appropriate units to represent independent and dependent quantities. This is taking it all the way back to our first unit, right? Independent quantity, dependent quantity. Make sure you got the right units attached to that, right? And choose an appropriate and interpret appropriate scales and origins for graphs of linear functions. You want to make sure you can see your stuff on your graph. You know what's what. So you've represented linear functions in a variety of different ways. How does each linear function representation compare with the others? So I would like you to take a look at the four of these: function A, function B, function C, function D. And I would like you to choose the function that does not belong with the others and justify your choice. Which one do you think doesn't belong and why? There's no right or wrong answer here, by the way. Just make a choice and decide. Hit pause, write it down, hit play when you're ready to check your work. So many choices here. Maybe you picked function A because it was the only one that was decreasing, right? Did you notice that the numbers on your y's were like going down? Whereas at function B, I mean, if the ratio is 1 to 1, up 1 over 1, up 1 over 1, we're increasing. Even function C, up 1 over 5, I mean, it's still increasing. Function D, also increasing, up and over, up and over. Maybe you picked a different one for a different reason. I mean, I just happened to notice that function A was the only one that was decreasing. The others were all positive and increasing. Maybe you picked a different one for a different reason. I don't know. So I would like you to consider the line that represents the equation y equals 4x plus 3. What things do you know about this line already? Hopefully, you're already noticing that your slope or your average rate of change is 4. Hopefully, you're also noticing that your y-intercept is 3. Okay, I'm sure these are things you already noticed. And here's what I'd like you to do. I have a whole bunch of different representations that I would like you to compare them with. I would like you to look at each of these. I've got A, B, C. I got a bunch of these on, well, you have a bunch of these in your book on page 75, M2-75. I'd like you to determine whether the graph of the linear relationship, and granted, they're not all graphs, but if you were to graph it, would it be parallel, perpendicular, or maybe not parallel or perpendicular to the graph of y equals 4x minus 3? This sounds to me like for every single one of these scenarios, you need to find the slope. You need to find the average rate of change. So find the average rate of change for every single one of these scenarios and compare it to that 4. Compare it to the rate of change that you've got going on right up here. And decide, parallel, perpendicular, maybe neither. Go ahead and hit pause, work your way through these, and then hit play when you're ready to check your work. So first things first, I'm just going to make a little note to myself. I'm just going to make a tiny little note to myself. Parallel, do you remember parallel lines? The slopes were the same. Perpendicular lines, whoa, my pen is not cooperating. Perpendicular lines, the slopes were opposite reciprocals. You remember this? Is this bringing back some memories? I hope it is. So let's start by finding the average rate of change. Let's find our slope. Pick 2 points, any 2 points. I don't care which 2 points you pick. I'm going to pick this one and this one because it seems like a good idea at the time. So we're going to subtract our y coordinates on top. I'm going to do 4 minus negative 6 on top, and I'll subtract my x coordinates on the bottom, 0 minus a negative 2.5. We don't like the double negative. Those become positives. So I actually have 4 plus 6, and now I can erase my funky writing because that's funky. So I actually have 4 plus 6 over 0 plus 2.5. So I have 10 over 2.5. If I grab my trusty calculator, if I grab my trusty calculator and I divide 10 divided by 2.5, I get 4. Hey, that's the same as this slope, isn't it? Oh, they're parallel. An elevator descends 4 feet every second. So let's talk about that rate of change. It's descending 4 feet every second. So it's going to go down 4 feet every second. So I'm going to say my slope is negative 4 over 1, right? Down 4 feet for every 1 second of time that passes, which means my slope is just negative 4. Well, it's definitely not parallel. And while this is positive and that's negative, they're not perpendicular because remember you have to flip it as well, right? Opposite and reciprocal. So this isn't parallel or perpendicular to y equals 4x minus 3. Fine, be that way. Let's talk about part C, which has a slope of 1/4, right? There's my average rate of change. There's my slope. It's 1/4. They just left it there waiting for me. I do see, because you could think of this as 4 over 1, I do see that they did flip it, but they didn't change the sign. So it's not parallel because they're not the same, but it's not perpendicular because they're both positive. Remember, they have to be opposite reciprocals, one positive, one negative. So it's not parallel or negative to y equals 4/3 x minus 3. Boo! All right, last but not least, our lovely graph here. Well, let's see what we got going on. I picked 2 points. So I picked this point, I picked that point. This point is 0, negative 1. This point is 4, 0. You could have picked any 2 points on this line that you wanted. Any 2 points on this line that you wanted. I picked those 2. So I will subtract my y's on top, 0 minus a negative 1. Subtract my x's on the bottom, 4 minus 0. The double negative does become a positive. 0 plus 1 is 1. 4 minus 0 is 4. I have a positive 1 over 4. We had this happen to us earlier, so it's not parallel or perpendicular either. Next up, E. Let's find our average rate of change. Again, you can pick any 2 points you want to pick. I just picked the first 2 because I'm too lazy to go any further down my table. So I just picked the first 2. So I subtracted my y's on top, 2 minus 3, subtract my x's on the bottom, 0 minus a negative 4, which becomes a 0 plus 4. 2 minus 3 is a negative 1. 0 plus 4 is 4. It's the opposite, positive, negative. It's the reciprocal, 4 over 1, 1 over 4. It's perpendicular. Yeah, I finally got a perpendicular one. It felt like it was never going to happen. For every hour Chiletzo, oh, I'm going to say that right. For every hour Chiletzo bakes, she makes 4 dozen cookies. So let's find our rate of change, also known as the slope. So she makes 4 dozen cookies per hour, per 1 hour, right? So I'm going to say 4 over 1, 4 dozen cookies for every 1 hour. That's amazing. So it's just 4. They match. They're parallel. Oh my gosh. So sweet. Let's shift it up a bit. You're sick of those. Let's shift it up a little bit. Large recycling centers pay out different amounts per ton of cardboard recycled. The Washington County Recycling Center lists its payout amounts in a table. So here's our lovely table. And Jackson County uses a graph to advertise its payout amounts. The two centers' payout amounts, they're close, but they're not equal. So each representation shows a functional relationship between the quantities. Can you just take a moment and just label stuff? Can you label what's our independent quantity or our input? What's our dependent quantity or output? And same thing on your graph. Can you label your x-axis, label your y-axis? Please, input, output. Hit pause, label all your junk, remember your units, and then hit play when you're ready to check your work. So this is how much garbage we're recycling, right? So this is the weight of our cardboard, and it's weight in tons. It did say per ton. Oh yeah, it said per ton of cardboard. Okay, so my independent is the tons of cardboard. My dependent is the payout amount in dollars, right? How much they give me. So that's going to be similar then for our graph for Jackson County. That means our x-axis is the weight of cardboard in tons. Our y-axis is the payout amount. How much money they're giving us. Yeah. Okay. So we're going to say that WX represents a function for Washington County and J of X represents the function for Jackson County. We have a couple of statements here, A, B, C. We got a few of these. I would like you to fill this in with greater than, less than, or equal to. Remember, alligator always eats the bigger one. Can you remember that? Please remember that. That'd be great. So go ahead, and that means you're going to need to do a little bit of work, right? You're going to need to, what do you get when you input 0.5? What do you get when you input 0.5? How much money do you get out of it? And let me know, less than, greater than, equal to. Hit pause, play with these, see what you get, and then hit play to check your work. So I was looking. W for Washington, right? W for Washington. So if I input 0.5, I get an output of $7.50. So I made a little note of that down here. For Jackson County, if I input 0.5, now this one is trickier. If I input 0.5, pew, I get an output right about here, 5, 6, 7, 8. Is that right? Not quite. It's divided by 4. Oh, that one's harder to figure out. I think I figured out, because Miss Scott can't count right. I'm going to try that again. It's not hard to figure out if you can count right. I didn't go up straight very well, did I? I'm going to try that again. So if I go straight up, which I should have done originally, it hits right here, which you can see is $10 there. It helps if I actually follow the line. So if I input 0.5, I get an output of $10. Hey, Jackson County pays more than Washington County. So I'm going to say that W of 0.5 is less than J of 0.5. Fair enough. What about W of 1 and J of 1? Hit pause. Do it. Hit play when you're ready to check your work. So hopefully you've now figured out this trick. So when we input 1, we get an output of $15. For Jackson County, when I input 1, which is all the way over here, we already know I seem to have a hard time making a straight line, but I'm going to do the best I can. I end up here, so I get an output of $20. Wow. Washington County, you're falling behind because you're still less than Jackson County. One more. W of 3, J of 3. Hit pause, work it out, hit play to check. So if I, 3 is not there. 3 is not there. So you know what I had to do? I had to do a little bit of work. I realized that if I go from 1 ton to 2 tons, I went from 15 to 30. So it looks like I've got $15 per ton. So that means a few things. That means so I'd have to do another 50. I would get another $15. So if I did a third ton, that would be another $15, which would put me at $45, wouldn't it? So it looks like we got $45 going on there. This one was trickier, but I did notice that when I went from I had 1 ton, which was 20, right? And half a ton, which was 10. So if I did 20 minus 10 over, and actually I'm gonna move this somewhere else just because I know it's about to be in the way, and I don't want it to be in the way. So if I do 20 minus 10 over 1 minus 0.5, 20 minus 10 is 10, 1 minus 0.5 is 0.5, and if I use my trusty calculator, 10 divided by 0.5 is, of course, 20. Oh, so this one's $20 per ton. So if I do 3 tons, 3 times 20, is going to give me, $60, isn't it? Ooh. So W of 3 is $45, but J of 3 is $60. So again, Washington County, you've fallen behind. What about the y-intercepts? And what does the y-intercept mean in terms of this relationship? Go ahead and hit pause, write it down, hit play to check your work. You do remember this was all about bringing in your recycling and getting paid for it for your cardboard. So if you don't bring in any cardboard, you don't get any money, which sounds like your y-intercept is 0 for both of these, right? 0 money is paid out for 0 tons of cardboard. That feels fair. So which recycling center would you choose? I don't know about you, but given that this guy was $20 per ton and Washington County was only $15 per ton, I'd be willing to do a little extra drive over to Jackson County Recycling Center, get a little extra money for my troubles. That's just me personally. As always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, email me or come see me, office hours, after school. You know I'm around, and I'll see you guys later. Bye.